everybody in Psych 200. Sorry for this kind of atypical format presenting the material. This is kind of the best way I thought we could get across things and stay up to date on stuff. But if this is anything that kind of confuses you, or there's anything I cover in this video that doesn't quite work for you and you don't have the ability to ask questions like you would in an in-person class, feel free to email me because I'm happy to try to clarify things, especially since we're going to have a quiz on not only the material from Tuesday's class, but this class when we come back, hopefully, to school on Tuesday, assuming that our power is back and everybody's able to have classes. So let's get started on today's topic. In our last class, we spent some time talking about different options we had when we were running what we called experimental studies. In particular, we started talking about the contrast between what's called between subjects designs and something called within subjects designs. In that class, we talked about how within subjects designs have a lot of advantage, sort of defined them, but talked a lot more about between subjects designs and when we would need them and certain things we would need to concern ourselves with if we did decide that a between subjects design was more appropriate for the experiment that we were running. As I mentioned before, we usually when we talk about the benefits of between subjects designs, we're talking about something that's necessary because of situational factors or the worry of contamination occurring. If we do have the ability to kind of avoid those things, the ones that we're going to be talking about today within subject designs are always ideal. Within subject designs, again, are studies where you're essentially running two different conditions, but the same people in those two different conditions. And as I mentioned before, there's a lot of advantages to doing that. Not only do you require fewer people, but you actually have a much better chance of being able to find something in your research if you do end up running within subjects design. I mentioned, though, all of these benefits are kind of nullified if we find ourselves in a situation where this within subjects design creation has some impact on things like carryover effects or other third variables that are of concern. Just understand why within subjects designs are so powerful, and kind of give you a glaring example of the real value of it. I was going to have us in class do this activity where we rolled up paper balls and tried to throw them in baskets and show a fairly obvious intuitive effect that trying to throw paper balls in baskets with your eyes open is significantly easier than trying to do it with your eyes closed. So what we were going to do in this activity is first split up people into two different groups and have them either be in one group where your eyes were closed or one group where your eyes were open, and we were just going to look at the averages of the two groups, trying to see if there was differences. But this would have led to a discussion of whether or not there maybe were other things that were causing some of the differences that we could see. We talk about whether or not athletes were more prevalent in one group versus another, whether or not luck had something to do with it, whether or not the individual differences that which is kind of inherent within people could have been playing a role in some of the differences that we saw between the smaller groups that we would have run in this study. Then what we would have done is transitioned to a within subjects design, where I would have had us kind of have one group do both conditions with their eyes open and their eyes closed. And what we should have been able to discover from this is that it seems a little bit more telling when we see big differences between the groups when we run these studies. Now, it also could have raised some discussions about concerns that we had if we did run this as a within subjects design. We might have talked about things like practice and other concerns. And this is exactly what we're going to focus on today, the benefits of these within subjects designs, but the concerns that we have if we do decide that this is the preferred design that we're going to run in our experimental study. Again, the big advantages of within subjects design is that we get to have way fewer people in our studies, and even with those fewer people, we get to have a much better chance of finding something if something is legitimately there. If there's no effect, if there's no real impact that our manipulation is having, it doesn't matter which type of design we're running, but if there is an effect, especially if it's a relatively small one, running within subjects design has a lot of utility. You're going to learn about this a lot more when you get into your statistics classes, but know that one of the biggest reasons why we have the ability to find something different in these within subjects designs is we have a lot more control. We get to control the groups that we're looking at, which tells us that if we're finding any differences between the groups, usually those differences can be attributed to the manipulation that we're running. One of the things that's really determinant of whether or not we find differences between groups in the first place is to have nice kind of control over what we call the variance within our groups, the wiggle room from person to person. Because when we're testing for whether or not something's different, we're actually testing it by calculating a ratio, the difference between the groups over the difference within the groups. And if we have low amounts of variability within the groups and there's lots of consistency, that means that just a small difference between the groups that we might find will give us the chance to actually what we call reject the null hypothesis, or confirm that there is an effect going on in whatever manipulation that we set up in our experiment. This, of course, does, though, lead to issues with whether or not there's other things that are maybe causing some of the differences that we find. Right? Sometimes there's these third variables that might peek in that we're not necessarily attending to when we run these within subjects designs. And just because we're running the same people doesn't mean we're running them always in the exact same situation, except for the manipulation. We might have, say, different research assistants running people in different conditions, other factors that people are experiencing in these different conditions that we're kind of unattuned to that are maybe causing some of the differences that we find. Other things that kind of pop up are just the kind of structure of when we're running people that can impact the differences or the significant results that we encounter. There are situations where just running people at different times of days might be a big factor in some of the results we have. That has nothing to do necessarily with the manipulations that we're generating in our study. Another thing that can sometimes pop up with these within subjects designs, especially if they're run over a long span of time, is that time overall tends to change people. Right? If some event occurs that causes people to behave differently in one condition to another, there's nothing to do with the actual manipulation going on. Right? It's really tough to account for these things in these types of designs. And also, if you're running a study that's looking at some type of performance and you're taking a long time, there is the possibility, especially if you're looking at younger participants, that these participants just might have matured, might have learned things and been doing so, and have learned to perform better in certain tasks that you're maybe running them through. There's also the possibility that there's some learning that carries over, and there's sometimes in situations just changes in the observers or in the instruments that you're using that could account for some of the differences that you're finding between the groups. This all screams that there's a possibility that maybe running within subjects design is not the best option in that case. There's, however, one thing that really is a red flag when you're running these studies, where you can't just kind of attend to it, think about how you can control for it, but instead you kind of might be forced to run a between subjects design. And it's these things that we call carryover effects, where essentially one particular encounter tends to lead you to change your behaviors automatically in the second encounter, regardless of what the manipulations are. These effects are about learning as well. This is when you're focused on trying to find a way to run a between subjects design, because within subjects designs simply don't work, because there's no real way to correct for these testing or learning effects or carryover effects if this is a component of the study that you're running. If we're looking at how we might be able to find these carryover effects, sometimes they're just intuitively recognizable. We see that if I give people a test, then they're probably going to do better on that test a second time around. Or if we expose somebody to some type of manipulation that kind of is involving deception, you can't deceive them again a second time around. Right? There's learning that takes place. Sometimes it's not as intuitive, and in that case, you're usually left to look for carryover effects through alternate means. One thing that you can do to kind of get a signal of these carryover effects is this inconsistency in what we call the variability of our groups. We talked about this actually in our between subjects design as a potential concern, where there might be a ton of variation in scores in one group and just a small amount of variation in scores in the other. Well, if we're running a within subjects design and we can counter this, usually that's a big indicator to researchers that there is some type of carryover effect going on. It's not necessarily that we're seeing scores naturally go up or down as a result of the carryover effect. It's the kind of lack of variability that tends to scream to researchers that maybe this is something that you have to monitor, or maybe something that you have to adjust for, where you might have to shift from what was originally within subjects design to a between subjects design. There are actual statistical programs that you're going to learn about when you get into your stats classes that can help you look for equal variability between the different samples if you do run a within subjects design. But I just want us to kind of be aware that that's one of the things that we tend to use to kind of look for the potential for carryover effects if they are there. Now, in some studies, we might actually be forced, even if we know there's potential carryover effects, to run a within subjects design. Maybe it's actually kind of an inherent part of the study or whatever it is we're trying to measure. It doesn't mean that we necessarily need to just abandon our research altogether if there is the potential for carryover effects in a within subjects design, but we might want to try to find a way to kind of tweak or adjust scores to account for those carryover effects. And one of the best ways to do this is to run studies where we do something called counterbalancing. Essentially, what you're doing with counterbalancing is for each participant in the study, you're kind of switching up the order of which condition they're presented. And this can allow you, when looking at carryover effects, to kind of gauge what the average amount of shift in terms of scores and variability is occurring for each person from condition to condition. It's allowing you to essentially say, look, every time I change people's scores, I see these differences in averages, but everybody seems to be upticking or downticking a little bit when they run in these different cases. Counterbalancing is a very robust technique that's used by psychologists who have large samples and enough data to actually be able to adjust their scores on, say, a second performance or first performance after they've learned what types of effects have taken place with respect to these carryover effects. Or if the differences in these effects are what we call asymmetrical, where one before the other has kind of a different impact than, say, the other one before the other one. I don't know if that made sense, but essentially, if you don't have equal carryover effects between the conditions, this counterbalancing is no value. But if it does actually have consistency, we can do a lot of things to kind of correct for some of the carryover effects that we encounter. One of the classic examples of a test that's actually looked for carryover effects and through this process of counterbalancing and been able to adjust to things is this classic test that social psychologists sometimes used called the implicit attitude test, or sometimes also called the implicit association test. This IAT actually allows people to participate in a variety of different conditions as they're trying to get at their true emotions. And what researchers have done, because there's so many people that have been run through this, have been able to calculate out things like how much faster we respond as we progress and how many more errors we make as we get fatigued. So they can look at our kind of preferences in different conditions or behaviors in different conditions, knowing that they have to kind of tweak the numbers a little bit to account for some of the typical things that happen to people as they're run in these particular experiments. It really does highlight the value of counterbalancing if it's done correctly, but it also does highlight the need, if you are going to do it, to have tons and tons of people in your experiments because of the other situations that could potentially arise. If this isn't sufficient, there are other things that you can do to try to kind of find a web between these between subjects designs that we talked about in the last class and the within subjects designs that we focused on today. It's something called a matched subjects design, where we essentially do the statistical analyses that we do with a within subjects design, but we run structurally a between subjects design by having two groups that actually run through all the conditions. With match subjects designs, what you're looking for is finding a way to find two people that you kind of deem equivalent and splitting them up into the two different groups that you're running. I guess if you had three different conditions, you'd need three equivalent people, or four different conditions, you need four equivalent people, and you split them up into the different groups. This particular type of design requires that you're very clear in why you think people are similar to each other, and that you're very consistent in kind of this matching process. But if you can do it, it does give you a lot more statistical power. Now, of course, it doesn't give you the advantage that you typically have within subjects designs, where you need fewer people. You actually need just as many people as you would need in a between subjects design. But the statistical boost that you get from these match subjects designs has been appealing to lots of researchers. Of course, if you don't have people that truly do overlap, all the benefits are kind of lost in the statistics of the analysis. So you really do want to find a way to ensure that if you're matching subjects, they're truly similar. That's why lots of match subjects designs usually involve the use of things like identical twins or people that have in some way, shape, or form kind of tested out to be almost equivalent to each other on something that's really pertinent to the study that's being run. Even though this is the case, there are still lots of people that are skeptical that we should be doing what we do with match subject design analyses, essentially treating them as if they were the same people. Those that argue that this doesn't work are people who tend to say that even if people might perform similarly on certain tests or be very similar in certain ways, it doesn't ensure that they're going to behave the exact same way in whatever experiment's being run. So it is something, if you move further into stats classes, that you'll learn is a bit controversial, and something there is an ongoing debate about what we should do with this particular approach. With that said, though, it is kind of a great place to end on these topics of between versus within subjects designs. I apologize if my child in the background, he keeps continuing to sing and make noise, is distracting. I can't really tell if he's going to be persistent in the audio or not. Of course, if you do need to clarify something, you can always just go back to the point where you lost me, and hopefully you can hear things clear. And that means that we are going to actually now move on to our next set of material. So on Tuesday, don't forget, we'll have our quiz day and mind tap day. And then after that, we're going to start talking about different types of designs. We'll talk about these things called time series designs and correlational tests. Essentially, we're moving away from what statisticians call parametric tests, something that we haven't really defined yet, but we'll kind of look at in our next couple classes when we really talk about how what we're looking at then is unique from what we've been discussing so far. So hopefully you got a lot out of this. Thanks for sticking through this, and hopefully this is just as useful as some of the stuff that you might get in person. I'll see you all on Tuesday, hopefully. Take care.